Welcome to another lesson of Advanced Higher Maths, and today we will be looking at how to split improper rational functions into partial fractions. So, an improper rational function is a sort of counterexample of the original rule I said for splitting things into partial fractions, which was that the degree of the numerator had to be strictly lower than the degree of the denominator. And in this video, we'll look at what to do if it isn't. So if the degree, let's say we have a fraction p of x over f of x, so if the degree of p of x is equal or higher to f of x, then we need to use the methods we learned in this video to split it into into partial fractions. So the way we do this is by first using algebraic long division to split this into let's call it p over q of x, to split this into f of x plus r of x divided by q of x. So q of x needs to remain the same in the denominator, but the numerator, by making this f of x plus something over q of x, well, we're decreasing the degree of the numerator. And this numerator will actually be, when you think about it, the remainder of the division that we did, right? So let's look at an example. First of all, without actually doing the partial fractions, just how to reduce it to a simpler problem. So x cubed plus 4x minus 3 divided by x squared minus 2x plus 8 cannot directly be split into partial fractions, right? We can't say that this is equivalent to a over, let's see, x minus 4 plus b over x plus 2, right? That's not true. And so we must first of all do algebraic long division on this. So it's going to be x cubed plus 4x minus 3 divided by x squared minus 2x plus 8. If you don't know how to do algebraic long division, there are many videos out there on how to do it. Everyone might be a slightly different method, so just choose the one you prefer, mainly layout wise. So anyways, if we divide it, we get this is equal to x, so minus x cubed plus 2x squared. I should have left a space here. Should be plus 4x, what did I say, minus 3. So plus 2x squared minus 8x, so 2x squared minus 4x minus 3 plus 2, plus 2, so minus 2x squared plus 4x minus 16, and so this is minus 19, right? And so our remainder here is negative 19. And so we can say that this is equal to x plus 2 minus 19 over x squared minus 2x plus 8, right? Because the remainder, to put it into the fraction, we're just saying this is equal to this plus the remainder over the denominator. Now, don't worry too much if you didn't understand how we got from here to here. If you didn't understand how we got all the way to this step, then just check out algebraic long division. And if you didn't understand how we got from there being negative 19 here to negative 19 over x squared minus 2x plus 8, just think of it as a general rule is the number that's left over at the end, you put it as a numerator and then divided by the original denominator, and you'll get more used to it as we do more problems. And so now this can be split into partial fractions. Not all of it, but this part here can be split into partial fractions. And so we're going to end up with something similar to, say, x plus 2 minus a over, so like we said, x minus 4 plus b, like this, b over x plus 2, right? We're going to end up with something similar to this. This isn't going to change, right? X plus 2 is already nice and simplified. It's just this part on the right that's going to change. So let's look at another, in fact, let's not do another example. Let's actually solve this one first, right? So what we're actually tasked with doing, now that we've got this, is simply splitting 19 over x squared minus 2x plus 8 into partial fractions. So the first step is to factorize the denominator, so x minus 4x plus 2. So you can see this is distinct linear factors, so it's quite simple to split apart. This is just going to be equal to a over x minus 4 plus b over x plus 2, which means I'm just going to speed through this process just for time, to a x plus 2 plus bx minus 4. You should be really good at this part by now. Now we substitute to solve, so if x equals 4, then 19 is equal to 2a. That's some nasty numbers. Did anything go wrong perhaps? Maybe not. We'll suppose it's correct. Tell me if I did get anything wrong. I did get something wrong. That's still nasty numbers. Oh well, nasty numbers sometimes appear. Do tell me down in the comments if I did do anything wrong. I hope not. So, that being said, this means that a is equal to 19 over 6. Now if we substitute in x is equal to minus 2, then we get that b is equal to negative 19 over 6. And so plugging this back into here, 19 over x minus 4 x plus 2 is equal to 19 over 6 x minus 4 minus 19 over 6 x plus 2. And so now this isn't us quite done yet, because we need to put it back into this original expression. And so this is the original expression, so this is equal to x plus 2 minus, and then in brackets, 19 over 6, oh, that 6 is not meant to be 0, 6 x minus 4 minus 19 over 6 x plus 2. And so by expanding the bracket, the negative and the negative make a positive, so x plus 2 minus 19 over x minus 4, 6x minus 4, sorry, plus 19 over 6x plus 2. And so now we've successfully split this here into full partial fractions. So let's look at a second example so you get the hang of this. So we have 2x cubed plus 5x squared minus 26x plus 11 divided by x squared plus 2x minus 15, and split it into partial fractions. So technically you should be able to do this by yourself, not question mark, just partial fractions, exclamation mark. So have a try and see how much you can do of this. Alright, so I'll assume you've tried. And we're first of all, of course, going to start by doing algebraic long division to reduce this. So we're going to be dividing by x squared plus 2x minus 15. And what are we dividing? We're dividing 2x cubed plus 5x squared minus 26x plus 11. And so now just doing the division. If I was bothered to put a time lapse on this, I probably would, but my lack of video editing skills means that I absolutely won't be doing that. 4x squared plus 30x, that's x squared plus 4x plus 11 plus 1 minus x squared minus 2x, that's 2x plus 26. So this is our remainder, right? 2x plus 26, and now we've achieved a lower degree than this, and so now we can put this into a fraction and split it into partial fractions. So the original expression here is equal to 2x plus 1 plus 2x plus 26 divided by x squared plus 2x minus 15. And so now all we have to do is split this fraction here into partial fractions. So if you didn't understand this part, at least give this part a go. It'll be a good practice for your prior skills. Alright, so 2x plus 26, and then if we factorize the denominator, we get x plus 5, x minus 3. That's going to be equivalent to a over x plus 5 plus b over x minus 3. And so you can go through the steps if you want, but 2x plus 26 is therefore going to be equal to a x minus 3 plus b x plus 5. And by plugging in values, let's say x is equal to -5, we get, so this disappears, this is -8a, and this is, so -10 plus 26, which is 16, which means that a is equal to -2. And now if we plug in x is equal to 3, the a term disappears, we get that 8b is equal to 6 plus 26, which is 32, so b is equal to 4. So a is equal to -2, b is equal to 4, which means I'm going to have to flip the page and remember everything, whatever. So plugging in back into our original expression, we get that, so a is -2, so -2 over x plus 5 plus 4 over x minus 3, but that's just our end fraction over here. We need to put it back into the actual original expression. So 2x plus 1, sorry my voice is going, I've been sick with a cold all day. So, where were we here? Minus 2 over x plus 5 plus 4 over x minus 3. And so this becomes 2x plus 1 plus 2 over x plus 5 minus 4 over x minus 3. So we've successfully split this quite large fraction into partial fractions, which we'll see their use quite soon when we get onto integration after doing our practice problems for the topic. So see you in the next video.